The third way of calculating delta H reaction is using Hess's law. Personally, this is my favorite way. I'll explain why later. Having 3 highlighters will be helpful when we go over an example. So let's go ahead and just talk about this first. So in the beginning, 6.0, that is the section that I made up, I said that enthalpy is a state function. So that means that the amount that we have, aka the amount of moles we have of something, will actually affect the enthalpy. Because if I have more moles, I'll have more heat involved. And so that's why it's related to state function. So Hess's law is a way of calculating delta H reaction. So here's why this is even a thing. So if I'm going from reactants to products, and there is some weird roundabout way of doing it, we can get the delta H reaction some way by going through multiple steps. This is something that's done a lot in industry when you're trying to make a lot of material stuff. So if you're interested in becoming a material chemist, this is a very handy thing to know. There's other chemists that use it as well. That's just the one that I can think of off the top of my head that uses this a lot. And so if I can go from point A, which was reactants, to point B, which is products, using various steps, then great, we can do it. And so what happens is you can couple different reactions to go from reactants to products. And if you're like, what is Mags talking about? Don't worry, I'll show an example and it'll make total sense. Okay, so there are rules to memorize. I know it's unfortunate. You have to memorize some rules, but oh well, it is what it is. So if I need to have a reaction and I need to reverse it, so instead of being whatever reactants making products, I need to change those so the products are now reactants and the reactants are now products, you're going to change the enthalpy sign, the delta H sign, because obviously if it was exothermic in one direction, then it'd be endothermic the other way. So make sure you know that. The other rule, so yeah, exo, endo, tomato, you know. And then if you're multiplying a reaction by a number because I need like 2 of those or 3 moles of that reaction, then you have to multiply that delta H also by that number. So if I have a reaction, I needed, let's say, 5 moles of that reaction. That means that delta H's reaction is going to be multiplied by 5. So that's just literally math. Cool. And then we have reactions. So if I can add them together to get the overall, then I can take all of those delta H's and also add them up to get the overall. And if again you're like, what am I talking about? I'll show an example. So like I said here, you're adding the delta H's for each reaction. Okay? Cool. Okay. So in summary, what the heck was I talking about? Okay, so if I have a chemical reaction I'm trying to get to from reactants to products, I can use various steps to get there. I can use different reactions to get from point A to point B, okay? And so I go ahead and manipulate those steps in some way, again, reversing it or multiplying it, potentially dividing it, that kind of thing. I do some math. And then I get my delta H. Again, this is the third way of getting delta H reaction. So I went over bond energies, which was 6.7. 6.8 was the formation way. And then now this is the Hess's law way. Okay. And so we mess with those steps to get whatever we're trying to get to. And we could combine a whole bunch of stuff. So we can combine the delta HF. We can get the delta H reaction from a different reaction. We can also use delta H com being combustion. All right, so what the heck did all that mean? So this is where the highlighters or colored writing tools come in. Essentially, how I like to think of Hess's law, I think of it like a puzzle. I am trying to get to this reaction here. So that's what I'm trying to solve for. I have 3 puzzle pieces, and I can mess with these puzzle pieces in order to get to this point right here. Okay? And so let's talk about that actual process. So just to repeat myself, the orange arrow that I just put up, that is the reaction we're trying to get to. And we have these 3 different steps we can potentially use to get to that orange step. So you're going to mess with those 3 different steps by using Hess's law until we get that orange arrow, the overall reaction. So I'm going to label these first, second, and third. And so I'm going to talk about what I need to do to each of those steps in order to get, again, the overall reaction. So this is where, the color coordinating is going to come into play. So first step is this one. So notice I have highlighted the NH3 here and the NH3 here. They are not in any other reaction except this one in terms of the steps. And so since we have 2 NH3s on the product side, well, first of all, I only need 1 because the overall says NH3. The second thing is I need to flip it. Okay? And so second step, I have CH4. So CH4 is over here. But then in the original reaction, CH4 is here. So you want to be careful about that because that is what I need to flip. So that's the coloring I showed here. Then the third step, I have HCN. So I have it in this color right here. This is the original. This is the step. And so I noticed it's 1 mole versus 2. Cool? Cool. So again, first step, it has 2 NH3s. But there's only 1 NH3 here. It's also needing to be on the reactant side. This just needs to be on the reactant side. This needs to be 1 mole rather than 2. And so, pretty much, as you can see here, I kind of hope the rest works out. It does usually. If it doesn't, then you need to start over. So I just mess with the main points, and then I just hope the rest will cancel out eventually. And you just kind of try it out. Again, it's like a puzzle. So I'm going to go ahead and show the things I just said out loud, in writing. All right. So I'm going to summarize what I said next to these steps here. Okay. So for this first one, we need to reverse it and we need to divide by 2 because we need to get to 1 mole because this is a product but needs to be reactant. Second step, I just need to reverse it because CH4 needs to be over here. And then for the third step, I just need to divide by 2 because it's only 1 mole here. And so I'm going to do each of these down here and show what I mean. So I'm going to do all that multiplying and dividing action with these different steps. Doing improper fractions is fine because it helps. So, yep. All right. So that first one, I'm reversing and dividing by 2. So I divide by all the coefficients by 2. And I also reversed it. So reversed, NH3 is now a reactant. I divided by 2, like I said, and every single one has to be. The N2 originally was 1 mole, so now it's half. And then the H2 is 3 halves, because again, it used to be 3. And then the delta H, I have to do the same exact thing. So just going all the way across, the delta H was originally negative 91.8, but because I flipped the reaction, that flips the sign, and then since I divided the reaction by 2, I divided the delta H by 2. And these are the delta H reactions of these steps. Cool. Then I have my second step. So CH4 was flipped to the C and the 2 H's, and so I just flipped the sign. It used to be negative 74.9, but now I have 74.9 positive. And then I have the third step, which is just dividing the whole reaction by 2, and then I divide the delta H by 2. All right. So now I'm trying to get to the overall reaction. So the overall reaction is here. And so the first thing I'm going to do is add up these steps after canceling stuff out. So 2 ways of doing it. You can either cancel stuff out now and then see if you get the overall reaction, or you could just add up all the reactants all together, arrow, add up all the products together, and then see what cancels out. You do what's the easiest for you, okay? I'm going to cancel out first because I prefer to do it that way, but again, you could do it the other way if you'd like. All right, so I'm going to start canceling stuff out. So notice that I've highlighted these to show reactants and products easier. So I'm going to find what reactants and products are on the same on all three steps. So for example, I have half of an N2 as a product here. I have half of an N2 as a reactant here. So those cancel out. I have a carbon as a product and a carbon as a reactant. So that cancels out. And then, if you notice, I have half a H2, and then I have 3 halves and 2. I'm going to mess with the 3 halves one, so if I get rid of a half here, then I have 2 out of 2, which essentially is just 1 H2. And so now I'm going to cancel this out too. Now I'm going to add up the reactants, add up the products to see if I get the overall. So I have NH3, so I have NH3 as a gas. And then I have CH4 as a gas. So that's just, getting it from here. I have an arrow. And then on the product side, I have H2 here. I have 2 H2s here. So I have a total of 3 H2s. And then I have HCN. So I double check. Are the things up here matching the things down here in, proportions and all that? So NH3, I definitely have that. CH4, I definitely have that. I only have one of each. Great. I have HCN down here. I have 3H2. I have 3H2. So all of the stuff that I did to manipulate these 3 steps, they are all correct. So the last thing to do is get the delta H reaction. So delta H reaction is literally just adding up all of these. So when you plug that into your calculator, you add all those up, you're going to get 255.95 kilojoules per mole. Now, is there sig figs for delta H reaction? No, these are all definitions that are standardized on a chart, so just write down a bunch of digits. If it becomes a crazy amount of numbers, then don't do it. So this is how you calculate this. Again, it's just a puzzle piece where you move stuff around, divide or multiply, and then you get your answer. Cool. So I'm going to clear the screen. I'm going to show the second way of doing this problem. Again, you pick the way that you like, but I'm going to do this exact same problem again, slightly different. Okay, so the second way of doing it is literally just adding all the reactants up and then adding all the products up. So looking on this side, so I have NH3. I'm not going to write the states of matter because I'm lazy. And then I got CH4, and then I got half of an H2, and then C, and then half of an N2. And that should be all my reactant side. Cool. Then I got my product side. I have half of an N2. I have 3 halves plus 2. So to make this into an improper fraction, that's going to be 4 halves. So 4 plus 3, that's going to be 7 halves. So 7 halves of H2. And then I have my carbon from here. And then I have my HCN from here. Cool. So now I have to check what cancels out between reactants and products. So I have half a nitrogen here and here, so that cancels out. I have my carbons canceling out here and here. And then I have half of an H2 over here. And so this ends up becoming 6 halves. And so I can change 6 halves to be 3. And so my overall reaction, I'm not going to rewrite it, is going to be NH3 plus CH4, arrow, 3H2 plus HCN. That indeed matches the overall reaction. And so I can go ahead and add all those delta H's, which is exactly like I showed you previously. So you pick the way that you want to add up these steps to figure out if it gets the overall. Again, you do it how you want. The first way is the way that I usually do it. This second way, other students love doing it this way. So pick the one you like. All right, it is your turn to puzzle piece time. So we have the overall reaction given here on the top. I have the 3 different puzzle pieces over here, and you're trying to get the delta H reaction of this guy using the delta H reactions of these 3 steps. So go ahead and pause this video, try this out yourself. This is again puzzle piece time, and then I will go over it in a few moments. Ready? Here we go. So I have highlighted here the main parts, the easier parts, right? Just like in the example problem, I dealt with, some parts but not others. So I've highlighted the parts that I think you should focus on. And so in the first step, I have CO2. I'm not going to do anything to it because in the overall reaction, it's on the product side. It's 1 mole. Here, it's 1 mole, and it's on the product side. So it's chilling. Leave it alone. I have SO2. So SO2 in the overall has 2, but this is only 1. So it's going to multiply that out. Cool. And then I have the CS2. I have it as a reactant here, but I have it as a product here, so I'm going to go ahead and flip it. And so I go ahead and do that here. So I explained what I did. I multiplied the delta H by 2, and then this one I changed the sign because I flipped the whole reaction. So in this example here, I'm showing it the different way of doing it, where you just add up the reactants together, add up all the products together, and then cancel out your things. But again, you pick the way that you like. So if I did add up both sides, I noticed the carbons match, the 2 S's match, and so those cancel out. I have this over here. My oxygens become 3 O2 because there's 1 over here and 2 over here. And then I get this. It matches the overall reaction. Fantastic. And so I can just go ahead and add up all those delta H's. And so you can see here, I got the different delta H's from the 3 steps here, here, and here. Add those up, and then I get a negative delta H reaction. And so that means it's exothermic. So that is pretty much it for Hess's law. It is a puzzle. You are taking, 3 or 4 or even just 2 steps, essentially, and you're trying to get from reactants to products using these steps. Make sure to memorize the rules you need to remember for Hess's law, and then it's puzzle piece time. So I personally like this way because I just love puzzles. And so there you go. All right. Bye.